Dear students, now we are going to discuss half subtractor and its logic diagram in detail. Let's start with the definition of half subtractor. It is a combinational circuit that performs the subtraction of two binary digits. Simply, it represents the subtraction of two bits. It accepts two bits as inputs and produces two outputs. The two outputs are a different and a borrow. This is the general diagram of half subtractor. A and B are the inputs, difference and borrow are the outputs. So before going to discuss the truth table, let's see the basic binary subtraction rule. So here we are going to subtract B from A. So here B is the subtrahend, A is the minuend. If 0 minus 0, the difference is 0. 1 minus 0, the difference is 1. 1 minus 1, then the difference is 0. So consider this case 0 minus 1. So in this case, the minuend is smaller than the subtrahend. So we are not able to subtract 1 from 0. So for that we have to borrow 1 to this minuend value. Now this minuend becomes 1 0 because we have borrowed the value 1. So 1 0 minus 1, then the difference is 1. We have borrowed the value 1 here. Okay, so here borrow is 1, difference is 1. So that's what given in this truth table. The table relates the input and output combinations. For two inputs, there are four combinations 0 0, 0 1, 1 0, 1 1. As we discussed in this basic binary subtraction rule, 0 minus 0, difference 0, borrow is also 0. 0 minus 1, the difference is 1 and borrow is also 1. As I told you, the minuend is smaller than the subtrahend. We have to get borrow value. Okay. And then 1 minus 0, the difference value is 1. The borrow is 0. There is no borrow. And 1 minus 1, the difference is 0. Borrow is also 0. Okay. Next we are going to draw the logic diagram for half subtractor. For that we need to obtain the Boolean expressions of difference and borrow. In order to obtain the Boolean expression, we are going to use Karnaugh map method. So here K-map simplification of difference. Since we are using only 2 bits, we are going to draw 2 by 2 table for this K-map method. So here difference values are mentioned in this K-map. A, B. 0 represents A bar, 1 represents A. Here B, B bar, B. So 0, 0 combination, the difference is 0. 0, 1, its value is 1. 0, 1, its value is 1. 1, 0. Here it is 1. 0, its value is 1. 1, 1, its value is 0. So now we have the higher bit 1 for these two combinations. So we can write the Boolean expression like this. Difference is equal to A bar B plus A B bar. It is equivalent to the operation of XOR gate of A and B. So we can write A bar B plus A B bar as A XOR with B. So now we have obtained the difference expression as A XOR with B. Similarly, we can obtain the Boolean expression for borrow. So as we know, the borrow is generated only for the combination of 0, 1. 0 minus 1, at that condition alone we are getting the borrow 1, right? So here we can write the expression as A bar B. So we have obtained both difference and borrow expressions. After that we are going to draw the logic diagram of half subtractor. So A and B are the inputs. Both are given as inputs to this XOR gate to obtain the difference value. Here the A is inverted. So inverted means it is NOT gate. So NOT gate is used to invert the input signal here. So A becomes A bar or complement of A. So A bar and B both are multiplied using AND gate. Then we can obtain borrow. So this is the logic diagram of half subtractor. It is similar to that of our half adder, but in half adder there is no NOT gate. NOT gate is not used in half adder, but in subtractor we are using this NOT gate. That is the only difference. Okay. So next, limitations of half subtractor. It is not suitable in practical application because it is only used for 2-bit subtraction. So it is not used in multi-digit subtraction. So that is the major drawback of half subtractor.